Hi and a very good morning to both panels, Encik Hassan Binatang and Dr. Kanaratif. My name is Khoo Kah Eng from Course 4 BMMD Section 1/2. Today, I would like to present about my final year project which titled Design, Analyze, Simulate Stair Climbing Trolley Manual under my supervisor, Dr. Muhammad Bashir bin Ali. So as an introduction, a trolley defined as a hand truck on an L-shaped moving handcart with handles and installed wheels at the bottom end, which function to carry and transport heavy loads or objects of various quantity from one place to another. The history of trolley or handcart can be traced back to history second millennium before century. Nowadays, the trolley has well developed into various types and functions, such as folding trolley, platform trolley, shopping trolley, etc. Therefore, the usage of trolley become common and demanded to carry and transport the loads or objects with more effortless from one place to another. So, as the first problem statement, the existing conventional trolley fail to lift or transport loads over the stairs. Second, the advanced transportation device or handling tool existing in the market are specially designed for the industry use, which is less affordable for the user who belong to the lower income group, such as the B40 group. For the objective of this project, the first objective is to develop a new design of the manual stair climbing trolley. Second, simulate and analyze the structure of the manual stair climbing trolley with the selected software. So for the scope of this project, the manual stair climbing trolley is able to climb at least 5 steps of stair, low product and maintenance costs, lightweight design for convenient and user-friendly, lastly, mainly focus on the user that working at building below 5 level and without built-in lifting device. In this project, there are three main categories of studies or research are being carried out, which are the type of trolley, basic component of trolley, and lastly, previous design study. So for the types of the trolley, generally there are five main types of conventional trolley existing in the market. They are upright hand trolley, platform or tire trolley, folding trolley, cage trolley, and tool trolley. Next is the basic component of the trolley. The main component of the trolley are body, frame, chassis, wheel, axle, and bearings. In this study, each specifications and details function of each component will be analyzed and studied for the implementation of the design. Next is the previous study design. In this research, total of three previous design of the stair climbing trolley are being studied in terms of advantages and limitations of the design, which are the first one, pedal-powered stair climbing trolley by Shiba Ganesan. Second, tri-star wheel stair climbing trolley by Sunil Kumar. And last one, Blanco stair climbing hand truck by Shakovic. Next is the methodology of this project. In this chapter, the process flow and the proposed methodology of this project will be covered. So the flowchart shows the overall process flow of this project from the early beginning until the ending of this project. So as for the proposed methodology implemented in this project, total number of 6 process and methods are included, which are survey questionnaire, household quality, morphological chart, Hughes method, 3D modeling, and finally, finite element analysis. The very first methodology is the survey questionnaire. The survey consists of 10 questions and being distributed towards the 50 respondents at different avenues of the building that below 5 level that without built-in lift or escalator by using the Google form. The questionnaire is divided into three sections. Part A is to identify the personal information of the respondent. The part B is to identify the views and the problem statement. And lastly is to determine the requirements and specifications. So based on the result from the survey, the results are being analyzed and carried out in development of the house of quality to identify the specifications priority in the design development. The figure shows the house of quality developed from the result. Next is the morphological chart. The morphological chart used to list all the possible design and options for each group component of the trolley. All the options listed will be combined to generate the design concepts of the trolley. From the combination result from the morphological chart, total of three concepts are developed. The figure shows the sketching of each concept developed together with the options selected. Next, the Q matrix evaluations is being used to evaluate among the three concepts with all the considerations and the selected criteria. From the result, concept 2 has the highest ranking and being selected as a finalized design to proceed the development. After the 3D modeling of the finalized concept is completed, the FEA analysis will be carried out to analyze the structure of the trolley. To carry the FEL analysis, there are several steps to carry the analysis, starting by apply the respective material, apply fixture, apply the load required, and then create mesh before run the solver for the simulation. Next is a result and discussion of this project. The results covered in this chapter are 3D modeling of the trolley, structure analysis, and also simulation analysis. From the finalized concept design, the completed 3D modeling of the trolley is being generated and assembled with the proper dimension and scale by using the SolidWorks 2018 software. The figure shows the 3D modeling of the manual stair climbing trolley that are being developed. The figure shows the standard 3 views of the manual stair climbing trolley respectively. Next, the figure shows the exploded view of the manual stair climbing trolley together with the view of material listed in the table beside. And now I will show the simple assembly animation of each of the components of the manual stair climbing trolley. Next, the figure shows the assembly of the climbing mechanism for the stair climbing trolley. So, this animation briefly shows the demonstration of the mechanism design. When the brake lever is being pulled, the pulling force will slide the gear track upwards, thus rotate the one-way gear, which eventually spins the axle. After release, the gear track will slide back to the original position freely, and repeating step will assist the trolley to climb over the step. Moving to the structural analysis of the trolley, load analysis is carried out to determine the load capacity of the trolley. By using the maximum bending stress of the plain carbon steel axle and the factor safety of 1.5, therefore, the allowable bending stress for the main axle can be determined together with the maximum load of the design. Based on the result from the calculations, the maximum load that the design axle can carry is 1025.42 Newton or 104.53 kilograms. The figure shows the P-body diagram of the chassis thrust of the trolley with a maximum obtained loading of 104.53 kg or 1025.42 Newton distributed load on the chassis. The method of joint calculations is being used to determine the axial force and the behavior of each beam after the loading. Based on the calculation result, force AE is obtained with the highest value compared to the others, which shows the tensile force of 552.557 Newton. So moving to the simulation analysis of the trolley, total of three main parts of the trolley, which are the main axle, tri-star plate, and chassis, are selected to undergo the FEA simulations in SolidWorks Simulation Workbench. These analysis results are interpreted respectively into three main plots, which are von Mises stress plot, displacement plot, and also the factor of safety plot. So for the first part is the main axle. From the von Mises stress plot, the maximum stress obtained is 148.151 megapascal, which indicated by the red color contour, and the minimum stress obtained is only 0.017 megapascal, which represented by the blue color contour. By comparing to the simulation results with the theoretical results that obtained from the loading analysis, the stress obtained was 147.063 megapascal. Therefore, the theoretical calculations are considered correct to the simulation results, which is only 0.74% of error. So next, from the displacement plot, the graphics show the deformed results under the load of 1025.42 Newton with a deformation scale of 533. The result shows the maximum displacement value is only 0.165 mm, which can considered be neglected on the middle area of the axle indicated by the red color contour. From the factor of safety plot, the result shows the minimum factor of safety is 1.5 after the maximum load is applied, which indicated by the red color contour. This shows that the main axle is able to withstand the load at least 1.5 times. By referring to the theoretical calculations, the factor of safety that being considered also shows similar value of 1.5. This can conclude that the design of the main axle is considered safe under the load with a 25 mm diameter. Next is the simulation result of the tri-star plate. Similarly, the selection material of the tri-star plate is plain carbon steel and apply the same maximum load of 1025.42 Newton to the two bottom arm that holding the wheels of the trolley. So from the Von-Mises stress plot, the value of maximum stress obtained is 53.027 megapascal under the maximum load. The induced maximum stress is lower than the yield stress of the plain carbon steel, which is 220.594 megapascal. Therefore, the design of the tri-star plate of the wheel frame is considered safe under the obtained maximum load. So for the displacement plot, the result shows the deformation of the tri-star plate under the maximum load with a deformation scale of 385.356. However, the result shows the arm only displaced 0.098 mm along the y-axis, which indicated with the red color contour and can be calculated since without any plastic deformation. Followed by the factor of safety plot, the red color contour represents the minimum value of factor of safety of the tri-star plate is 4.16 under the maximum load. This can conclude that the design of the tri-star plate is safe to withstand the maximum load without any failure or deformation. So moving on next is the chassis. The chassis is being simulated and analyzed to find out the stress distributions and deformations under the maximum load applied. The material of the chassis selected is the aluminum alloy 1060 and the similar maximum load 1025.42 Newton is applied to the platform of the chassis. So from the Von-Mises stress plot, the maximum stress obtained under the maximum load is 6.561 megapascal, which is lower than the yield stress of the material aluminum alloy of 27.574 megapascal. This verified that the structural design of the chassis is able to overcome the maximum load without occur any plastic deformation or failure. Next, the result from the displacement plot shows the deformation result of the chassis with a deformation scale of 951.749. The area that in red color contour represents the segment of the chassis displaced the most, which is only 0.103 mm after being loaded to the chassis. This shows that the design structure of the chassis is significantly safe to withstand the load without any crucial deformation. So lastly, for the factor of safety plot, the result shows the minimum value of factor of safety is up to 4.2 after applied the maximum load. Therefore, the chassis is considered secure to carry the load without any failure. So as conclusions, the selected concept idea is being developed into the 3D modeling with the proper dimensions and scale by using the SolidWorks 2018 software. With the whole completed 3D model, a new design manual stair climbing trolley is developed. The first objective of this project is achieved. Secondly, the structural analysis was conducted that consists of maximum bending, factor of safety of the manual stair climbing trolley. Besides that, the FEA analysis also being performed by using the SolidWorks simulation workbench to analyze the behavior including the stress distributions, deformations, and the critical part of the trolley structure. Therefore, all the objectives of this project are completed. So next is the recommendations. Although the purpose and objective of this project is successfully achieved, there are still some aspects and procedures that can be enhanced for a better result and solutions in upcoming projects. So the first one, the parts and components of the manual stair climbing trolley can be simplified in terms of quantity and capacity. The material selected for the chassis part can be replaced with alternate material if the trolley is purposed to carry the higher value of load. The FEA simulation analysis can perform with another alternative of software such as Analyse or Hypermesh. Lastly, the design concept can be developed to produce a physical prototype to determine the actual performance of the trolley. This is able to make the comparison between the simulations and the actual product in terms of load capacity and efficiency. Finally, I would like to say thank you for spending your valuable times for my presentations. Once again, and thanks for me. Thank you very much.